The moon keeps turning sophisticated spacecraft into scrap, not because it is mystical, but because it is precise. It punishes late data, miscalibrated confidence, and margins that looked fine on a slide. Landers fail when sensors disagree for a few heartbeats, when dust pretends to be ground, when the control loop believes a world that no longer exists. Nothing here is cinematic. It is timing, geometry, and heat. A powered descent is a choreography between three storytellers. The inertial measurement unit reports changes quickly but drifts over time. A laser rangefinder offers absolute distance but can be fooled by reflectivity and backscatter. A camera recognizes terrain if lighting cooperates and maps are trustworthy. The navigation filter blends them into one estimate of where the craft is and how fast it's moving. That estimate drives the throttle, and the throttle consumes the propellant budget. A 300 millisecond delay in range data near the surface can translate into tens of meters of unplanned freefall. At terminal phases, the target vertical rate is roughly a walking pace, 2 meters per second or less. Miss by an order of magnitude and structure turns into telemetry. Close to the surface, the ground refuses to stay still. Rocket plumes excavate craters in real time. Regolith behaves like electrostatic glass dust, not beach sand. Particles bounce, charge, and ride the flow, forming a dirty fog that blinds cameras and sprays later with false echoes. Boulders and shadows, sharp from orbit, smear into ambiguous texture under the plume's self-made weather. Sensors need to be angled and staggered, so a single fountain of dust can't wipe them all at once. Side-looking optics, higher hover-to-land transitions, and throttle envelopes that minimize recirculation help, but they cost fuel, and fuel is the only currency a descending vehicle truly holds. Autonomy is non-negotiable. Even when the moon is close, round-trip light time makes remote piloting a romantic daydream. Decision authority must live on the vehicle. That authority has to include the right to wave off. Abort is a success path when the alternative is a crater. Good playbooks make wave-off conditions explicit. Bad lighting, velocity mismatch beyond a strict bound, sensor disagreement beyond a budgeted threshold, or hazard maps failing to converge. Great playbooks pre-bias propellant and battery to make that wave-off survivable without heroics. Lighting geometry quietly dictates what works. Dawn gives kinder thermal conditions and long shadows confuse vision algorithms. Local noon supplies clean imagery and brutal heat. Thermal cycles drift camera intrinsics, soften battery performance, and make radiators beg for darkness. Dust on radiators erases performance exactly when power draw spikes for guidance and communications. A lander that chases midday optics without planning thermal headroom inherits hot electronics and a noisier estimator. A craft that chooses dawn inherits the opposite problem and must tune its vision to handle contrast and glare. Every answer is a trade. The irresponsible move is pretending it isn't. Engines carry personalities. Engineers must learn to anticipate. Throttle curves are not linear. In some regimes, a small command produces a big kick, and in others, a big command produces only a sigh. Gimbal dynamics couple with structure. The vehicle flexes, sensors echo that flexes motion, and the control loop chases ghosts. Valve chatter and combustion oscillations leak into the measurements you promised yourself were clean. The cure is frequency mapping, generous margins, and tests that make the stand shake the way the moon will. You don't get the right dynamics by babying hardware, and you don't get a reliable estimator by feeding it only friendly waveforms. Hybrid sensing wins when it's truly hybrid. Independent fields of view, independent timing, and simple cross-checks that survive chaos. Two sensors telling the same story with the same clock is not redundancy. It's a chorus with one conductor. Decouple clocks, add sanity checks more primitive than you think you need, and accept that during the worst seconds, one modality might carry the entire decision while the other is blind. Terrain relative navigation succeeds when the camera can still see real features, not dust clouds. Laser succeeds when the beam sees surface, not backscatter. The system must admit that either could vanish briefly and keep burning the right amount of propellant anyway. Margins must be bought on purpose. If your nominal trajectory lands with a 10% propellant reserve, you have no reserve. Bias the plan, so the first landing site can be denied without dooming the second. Write a fuel tax into the estimator for every cycle of indecision. And let engineers feel that tax in simulation. The cost will sting now and save you later. The only thing worse than landing with empty tanks is arguing with physics while you run out of them. Training should lie to you. Simulators should break timestamps, sprinkle dead pixels, rotate starfields by a fraction of a degree, and inject boulders exactly where you didn't expect them. They should make your sensor fusion choose between conflicting truths under time pressure. They should reward a clean wave-off with applause instead of disappointment. They should grade debate and listening, not just the prettiness of the plot after the fact. You want teams to hesitate for a breath when dissent appears, not because they're timid, but because they respect the cost of a wrong, quick answer. That breath is the room where vehicles live. Culture is upstream of code, and code is upstream of craters. A new guidance engineer notices a subtle bias in the altimeter pipeline during a late review, and considers staying quiet after last week's bruising critique. She speaks up anyway. The room slows down, and a corner case becomes a test, not a eulogy. A mission lead deletes 3 algorithmic news feeds before a critical rehearsal. Sleep returns, and with it, clean timing. A senior friend of the program keeps texting at midnight with emergency opinions until someone writes, kindly and firmly, that reviews happen in daylight in the document with data. These moves look small until you map them to burn profiles and throttle commands. Underneath the flight dynamics, logistics writes the long story. Landing once is craft, landing weekly is infrastructure. Pads must tolerate noise, flame, and neighbors. Towers must shrug at wind limits and support rapid stacking without stealing range time from other vehicles. Transport routes matter as much as thrust. The wrong road constraint will keep a booster sitting on a trailer through a perfect weather window. Refurbishment bays turn flights into cadence. A vehicle caught in a maintenance bottleneck might as well be a trophy. Environmental reviews, bird surveys, and evacuation routes look boring until the day they're the only reason your schedule still makes sense. The public sees a plume. The program sees a calendar. Power budgets are ledgers that must be closed nightly. Dissent wants watts. Comms want them too. Cameras and lidar pull hard. Heaters pull harder than you budgeted. Solar arrays beg for geometry and sunlight you may not get.
Write it down. Pay it.
Batteries hate cold and degrade under heat. A design that pretends you can have crisp noon imagery, nominal thermal margins, and generous comms windows simultaneously is really a design that has chosen optimism over arithmetic. Pick your pain and write down how you'll pay for it. More radiator, more mass, more insulation, less delta V, more autonomy, fewer calls home.
What looked like pebbles become
There is a
walls
persistent
and enemies.
temptation to believe that one clever algorithm can make the moon behave. Better estimation helps. Breakthroughs matter, but the truly durable improvement has always come from redundancy, discipline, and repetition. Make the estimator boring. Make the throttle predictable. Make the abort proud. Make the test resemble the failure you're scared of. Then fly, recover, fix, and fly again, before the lessons fade into lore. Cadence is not Flash. Cadence is how you convert luck into craft. Teams love triangles because triangles remind us that trade-offs are geometry, not poetry. Budget, sensing, and schedule sit at the corners. Pull one and the other two must move. If you want fast, you either simplify sensing or spend more. If you want exquisite sensing, you lengthen the schedule or spend more. If you want cheap, you accept coarser sensing or a slower march to flight. Pretending you can stretch one corner without paying somewhere else is how programs slip, rename, and quietly stop publishing updates. The surface itself changes how honest your tools will be. Near the poles, sunlight skims the horizon, creating long shadows that erase depth and saturate cameras, even as it offers thermal relief. Near the equator, the sun sits high, giving bright imagery and punishing heat. Terrain that looks flat can hide slopes that steal lateral control authority the instant the legs touch. Boulders that look like pebbles at altitude become walls at 10 meters. A hazard map that expects a certain albedo will lie to you if the regolith is unusually bright or dark. An altimeter calibrated in Earth labs can miss in vacuum when reflectivity and incidence angles stray from friendly values. The vehicle must be built to distrust its first impression. Why continue if the list of ways to fail is so long? Because landing is only step one, and staying is where knowledge compounds. Power systems that endured lunar night will teach us to stop fearing darkness. Life support that treats dust as a guest rather than a burglar will teach us to build habitats that welcome dirt without suffocating in it. Refueling plays that treat water as both air to breathe and propellant to leave will turn isolated missions into networks. The moon becomes a workshop where routines, not stunts, determine legacy, and routines demand that we solve problems in boring ways on purpose. The success image isn't a dramatic touchdown. Success is 8 telemetry plots that look unremarkable, a guidance filter whose variance stayed modest, a throttle profile that never kissed its nonlinear cliff, and a crew that seems a little bored because the play they rehearsed happened again in the same order. Success is a wave-off that brought the vehicle home, turned into a patch, and returned as a tame line on a future graph. Success is when we don't know yet buys time for experiments rather than panic. The moon is indifferent, not hostile. Indifference is beatable with margins, humility, and cadence. Put 2 independent ways to tell altitude on the vehicle and separate their clocks. Mount them so dust from one plume can't blind both. Give the estimator a simple veto and a cheaper fallback. Choose lighting as carefully as thrust. Budget fuel for the site you will not use. Train on the lies you are likely to see. Protect the boring pieces of the program from the urge to dazzle. Build pads where neighbors sleep, roads where transport fits, and schedules where maintenance breathes. And when the public asks why it looked easy this time, accept the compliment and get back to work.